following video will take users through the process of setting up a Sigma-7 drive and motor, and also introduce a lot of related topics and resources that are available to users. Start off with a quick example of just how quick the startup can be with Sigma-7 drives and motors, where we'll first make a connection between SigmaWin and the drive through USB. And then once connected to the drive, assuming all the electrical connections have already been made and the mechanical setup is fairly straightforward, we'll jog the motor back and forth, first at a low speed and then at a high speed. And all of this will be done without changing any parameters in the drive, and in total this process takes just about a minute. And the idea is to move the motor forward and backward at a low speed. We're using 10 RPM as shown in this example, and make sure that the motor is moving smoothly. And once you're confident of that, just change the speed. We'll disable first, change the speed to 100 RPM, re-enable the motor, and move forward and backward again. And in just about a minute, we have the motor moving. Now, admittedly, the drive and motor in a short example, we're in kind of an ideal condition where electrical connections had already been made, mechanical setup had been done, and load on the motor was very, very simple, just an inertia wheel. And so we could get to a point where we can move the motor around very quickly, still without changing any parameters in the drive whatsoever. Yet in reality, there are a lot of things that can happen during the startup process. And so the purpose of this video is to help users through the setup process by identifying related topics, tips and tricks that they can use along the way, as well as resources that are available to them from Yaskawa, not only for the initial drive startup, but also for later work with the drive and motor. Before going any further, it's important to remind you that you'll be working around live electricity as well as moving equipment. Safety precautions are provided in all of our product documentation, so please review that thoroughly before starting to work with your equipment. A physical copy of our safety precaution manuals are provided with each servo drive and servo motor that ships. Also, this information can be found in our separate product manuals for our drives, including 200 and 400 volt drives, as well as rotary servo motors, linear servo motors, and direct drive motors. These are just a few examples of the manuals where you'll find this information, but it is listed in all of our product documentation, and again, as a physical manual that ships with each of our drive and motors. Again, please review this information thoroughly before getting started with your motor and drive startup. Here's an outline of topics that will be covered in this video. First, an overview of the setup process workflow, from initial setup to considerations for further setup. Next is a review of where to find software, documentation, training, and other online resources. Several sections of the drive manual, which are very helpful during the setup process and further work with drives, will also be introduced. Next are the electrical connections that are critical to the initial setup, followed by recommendations for the initial mechanical setup related to the motor and any mechanics that it might be driving. An overview of the drive hardware interfaces for various Sigma-7 model drives. Next up are several topics relating to using SigmaWin with the drive, including opening the initial connection, a quick tour and overview of various tools within SigmaWin, how to read drive status as well as alarms, not only through SigmaWin, but also from the drive's front plate, how to access and change drive parameters, including several parameters which may be important to your initial drive setup, using SigmaWin's tools to generate and test basic motion, and last, an introduction to the SigmaWin trace tool, which can be used to record and display drive activity as a scope plot. Here's an overview of what the workflow looks like for the initial setup of a Sigma-7 drive and motor. First step is to download SigmaWin Plus 7 software as well as the user manual for the particular Sigma-7 drive that you're using. I'll show you where both of these are located on Yaskawa's website. The next step in the process is the initial mechanical setup. It's a good idea at this point to consider using an unloaded motor secured to a benchtop or a very simple mechanical load. Next are the initial electrical connections, which usually are the motor power and feedback, main power, control power, motor brake power, as well as communication, for example, USB. Once the initial electrical connections have been made, there may be some parameters which need to be modified, for example, specifying single-phase versus three-phase power, or a DC input bus versus AC. Also, there may be an alarm on the drive, for example, encoder backup not present, or encoder communication not possible. After the necessary parameters have been set and alarms have been cleared, you're all set to test out basic motion using tools within SigmaWin. This can include jogging, running point-to-point profiles, and also tracing and monitoring results. After the initial setup has been completed and basic operation has been confirmed, further setup includes tuning the motor and load for an application's required performance criteria, adding other electrical connections, for example, sensors tied to I/Os, safety circuits integrated with the drive, things of that nature. Also, this is where integration of the drive with the controller takes place. That controller can be an MPIC controlling the drive through a Mechatronic 3 network, a centralized controller controlling the drive via analog torque or velocity mode, or a PLC communicating with the drive through a variety of Ethernet protocols. There are quite a few resources available from Yaskawa's website to help with drive startup, including SigmaWin Plus software, product manuals, application notes, FAQs, and training videos. Product manuals and SigmaWin software can be found from the Drive product page on Yaskawa's website. To get there, navigate to the Products tab, then from there, the Motion Products section, and under Sigma-7 servo products, go to Servo Packs. Then from there, choose the particular type of drive that you'll be working with. As an example here, we'll use the single-axis Mechatronic 3 type drive. Product manuals can be found under the Documents tab in either the Core Manuals area or the Manuals All area. And then SigmaWin software can be found underneath the Software tab. For the User's Manual, we'll go back to the Documents and Core Manuals. And here you'll find the 200-volt Mechatronic 3 style Sigma-7 servo pack. And you'll also find, if you happen to be using it, the product manual for the 400-volt Sigma-7 servo pack, also Mechatronic 3 style. SigmaWin software can also be downloaded through this page by going to the Software menu, click Overview, then select SigmaWin Plus version 7. From here, download software, and you'll see both a zip file with the SigmaWin installer as well as usage notes, which include system requirements, installation instructions, troubleshooting recommendations, and things of that nature. Another resource that you can find available on Yaskawa's website are training videos. For example, our self-guided video training. In this area, for further drive setup beyond what we'll show today, you can see a series on servo tuning with Sigma-7 drives. Quite a few topics related to this area, all listed here. And to get to individual videos, you can go to either Yaskawa's YouTube channel or download page, which will show all the individual videos related to tuning a Sigma-7 drive. Another helpful area on Yaskawa's website is the Solution Center. This is an area containing application notes and FAQs, allows you to search for those among different product types as well as resource types. This next section is a quick overview of several sections of the Drive product manual, which may be very helpful for users going through the first time drive startup to be aware of. This is definitely not a comprehensive overview of the manual. It's important that users do read the manual carefully as it contains a lot of information critical to safely operating a servo drive and motor. One other note is that this segment will cover these sections using particular chapter numbers that are found in this model drive's product manual. Chapter numbers may differ from manual to manual by a little bit. However, generally the sections being shown here will also be found in those manuals. An overview of the different connections and areas on a servo drive can be found in the part names section, which is chapter 1.3 in this manual. This manual also shows an example of where the servo drive would fit within a motion control system. For example, wiring between a motor and its feedback in the drive, between a PC or PLC in the drive, as well as main circuit power and control power. Chapter 2.2 contains high-level electrical block diagrams. Basic wiring diagrams are shown in Chapter 4.2, which will show main input power as well as control power, motor power and feedback, I/O circuits, as well as safety circuits. Another helpful area in this manual is the power supply wiring diagram section, which shows connections for main power as well as control power. Here you can see diagrams for three-phase 200-volt AC input as well as single-phase 200-volt AC input, and an example showing DC power supply input. I/O signal connection details can be found in Chapter 4.5. Shown here is a table containing pinouts and descriptions for input signals. On the next page is a similar table for output signals with signal names, pin numbers, and function descriptions. Wiring examples for I/Os can be found a little bit further in Chapter 4.5. Here's one example here showing an entire I/O port. Then specific examples for photocoupler and relay circuits, as well as examples of syncing circuit connections, as well as sourcing circuit connections. A list of all available servo drive parameters can also be found in the user's manual. Chapter 13 contains a comprehensive list of servo parameters that are available. Each parameter begins with a PN prefix followed by 3 digits. The manual will include each of these different parameter numbers, as well as a description of what that parameter does, and also a link to other sections in the manual which describe in further detail what that parameter is and how it is used. Another helpful section of the user manual is the alarm display section. This contains a list of all alarms available. Alarms are abnormal operating conditions which result in the servo drive disabling power to the motor. Each alarm follows the following format: A dot and then a 3-digit hexadecimal number. You can see here the alarm meaning is also provided, as well as an indication if that alarm is resettable through software. When an alarm occurs, the alarm code will be displayed on the front face of the servo drive and also displayed through SigmaWin. Similar to the alarm display section, the warning displays provides a list of warnings available to be reported from the servo drive. A warning is a condition which will not immediately result in the drive removing power from the motor. However, if that condition continues, it will result in an alarm being reported and the servo drive disabling power to the motor. There are some electrical connections which are needed even for basic operation of a motor and drive. This section will cover what they are and what they're needed for. Control power will be needed because this allows for communication with the drive, for example through USB via SigmaWin, also through other communication methods such as Mechatronic 3 and EtherCAT. The main power to a drive allows operation of a motor, including enabling the motor, as well as jogging and positioning the motor. If you're planning to use DC voltage as the main power, be sure to set PN001.2 so that the drive recognizes it will be using DC instead of AC voltage. You can do this by first applying control power, communicating with the drive through SigmaWin, and setting that parameter before applying main power. If your motor is equipped with a brake, you'll need to apply power to it in order for the brake to disengage so that the motor will be able to move. This is usually 24-volt power, which can be applied to the brake directly for simple initial setup and testing, and can also be controlled through a digital output from the drive, which will engage and disengage the brake automatically depending on if the motor is enabled or disabled. The drive's HWBB inputs will also need to be connected to power. These are known as the hardware base block, or STO, which are safe torque off inputs, and also referred to as safety inputs. 24 volts needs to be applied to these inputs, otherwise you will not be able to enable the motor. All drives ship with the jumper for this connector, just to make sure that that jumper is in place, or that if using a safety circuit with the HWBBs, that those connections have been made. A battery for the motor's encoder may be needed if the motor is not equipped with a batteryless encoder and the application requires multi-turn absolute information. If your application does not require multi-turn absolute information, you can use the absolute encoder usage parameter, PN002.2, to set the drive to expect either only single-turn absolute position information or incremental position information. This is also a helpful trick in the event that a battery is actually needed for the encoder, where you might need multi-turn information, and the battery is not available. This can temporarily help avoid the 8.810 encoder backup alarm. Last is a USB connection for communication with our SigmaWin software. This will be used to jog and move the motor around after clearing alarms and editing certain parameters. It's a good idea to try to use Yaskawa's USB cable because it's been designed for maximum noise immunity. Other ways to communicate with SigmaWin to the drive are through our IEC controllers using Mechatrol Link 3 and also using EtherCAT, specifically Ethernet over EtherCAT. But USB is a great, simple starting point. Here are some recommendations for the initial mechanical setup of your system. Keeping it as simple as possible is the best starting point you can provide for yourself for the basic motion test will run. This is usually an unloaded motor, decoupled from the load, and not installed in the system, but rather sitting and secured to a bench top. Our initial setup will make use of our drive's tuningless mode, which is the mode that the drives are in by default, fresh out of the box, and it makes it possible to operate the motor without going through a tuning process. You'll get the best results from tuningless mode with well-behaved loads. What's meant by well-behaved loads are those that are rigidly coupled to the motor, where the load is low inertia, or that the load creates a low inertia ratio between the load and the motor. More complicated mechanisms may require further tuning and be beyond the ability of tuningless mode to handle them well. Some of the types of mechanisms that may be difficult for tuningless mode are those with high load inertia or high load to motor inertias. Also those which have very compliant drivetrains, such as highly flexible couplings, very flexible belts, and so on, may be difficult for tuningless mode and may require additional tuning. Other circumstances which may require further tuning include drivetrains and mounting structures which introduce significant resonances into the mechanical system. When using tuningless mode, you notice that there are oscillations like wobbling or high frequency noise after enabling the motor or while you're moving it. It's a very good indication that further tuning may be needed. This next section will give an overview of the hardware available on a drive, including electrical connections and other devices. A variety of drives will be shown here, including Mechatrol Link 3, EtherCAT, analog pulse, single-axis controllers. Drive versions are available for 200 volt and 400 volt main power. If your main power happens to be 100 volt, an option for that is available in the 200 volt form factor. Also, there are options for single-axis and dual-axis packages. And a quick reminder that the part name section in the drive's product manual gives a comprehensive overview of all the different connections and devices available on the drive, as shown here. In the single-axis 100 volt, 200 volt series, there are options for Mechatrol Link 3, EtherCAT, and analog pulse. The connections and interfaces for the Mechatrol Link 3 drive are shown here. More detail of what's underneath the front cover can be found in the manual underneath the product names section. That includes items such as address switches, diagnostic LEDs, and dip switches, depending on the drive model. Both the EtherCAT model and the analog pulse model share many of the same connections and interfaces as the Mechatrol Link 3 drive, with a few differences here and there. On the dual-axis drive, all the motor power and I/O signals for both axes are combined on a single connector, Motor feedback is broken out into two separate connectors, and the HWBB or STO inputs are located on the bottom of the drive. The 400 volt version drives have a slightly different form factor than the 100 and 200 volt versions. The hardware connections and interfaces are found on the front, top, and bottom faces of the 400 volt drives. On the front of the drive, you'll find the charge LED, front cover, and interface for the digital operator. The top of the drive is where the main power, either AC or DC, is located, as well as control power, motor feedback, IOs, USB, etc. And on the bottom drive are connections for motor power and an external dynamic brake resistor if you choose to use one. The layout of the 400 volt dual axis drive is very similar to the single axis version. There are some exceptions here and there. For example, the USB connection is now located on the front of the drive. On the top of the drive, you'll find connections for the HWBBs, motor feedback, and IOs for both axes. One note is that the IO signals for both axes are combined on one connector. Motor power and external dynamic brake resistors for both axes are located on the bottom of the drive. Locations of devices and connections on the 400 volt EtherCAT drive are very similar to locations on the Mechatrolling drive. Similarly, for the dual axis 400 volt EtherCAT drive, connection locations here are very similar to what we saw on the 400 volt dual axis Mechatrolling drive. The last products that will be covered in the Sigma-7 series are the single axis controllers, which are single axis programmable drives. These products share the same form factor as the 200 volt drives and also have devices and connections found in similar locations. You'll see the Sigma-7 SIEC, SigmaLogic Compact, which happens to be a single-axis controller designed specifically to work with Allen Bradley PLCs via Ethernet IP, and last is the MP2600 IEC. There are some slight differences in the hardware interfaces here and there, but generally you'll find a lot of similarity among these products. To connect to the drive through USB, first click on the Home menu at the top left-hand corner of SigmaWin, connect with Servo Pack. This is a screen where you'll be able to search for servo packs that are connected to your computer through USB. You'll see the option here on the next screen. All the way to the left is where you'll find the USB connection option. Click on Search for Servo Packs. And at this point, SigmaWin will search for any servo packs connected via USB. This could be a single drive connected through USB to your computer, or it can be multiple drives connected either through individual USB connections or through a USB hub. If SigmaWin has any trouble communicating to the drive via USB, this is the point where that will be noticed. We'll show a couple of resources available to help troubleshoot such communication issues in a little bit. After the search process is complete, you'll see all of your USB drives listed on the screen. Select the drive or drives that you'd like to connect to, and then click on the Connect button. Once SigmaWin is finished connecting to the drive, you'll see it shown towards the top left-hand corner as an individual control panel. This could be a single drive, or if you've decided to connect to multiple drives, you'll see each of those shown here as individual control panels. A couple of other communication methods worth noting are connecting to a network of drives through either an MPIC or through EtherCAT. If SigmaWin experienced any issues communicating with the drive, it might be a good idea to check and make sure that the USB driver was installed correctly. On our website, through our Solution Center, you'll be able to find a technical note which describes the USB driver installation process. A good way to find it is by searching for USB SigmaWin. And shortly down the list, you'll see a technical note for the USB driver installation. This is a very helpful and detailed note. However, if you continue to have communication issues, please feel free to contact our tech support at 1-800-Yaskawa. In this next section, we'll take you on a tour of SigmaWin and show you some of the commonly used and very helpful tools throughout the software. SigmaWin has some tools that you'll be able to access without being connected to a drive. Go to the Home menu, and the first one will show is the Help. It's a very extensive built-in help file. Go to the Help item and then Display Help. The SigmaWin help file will open in a web browser and take you directly to the table of contents, where you can see that there are sections relating to navigating through SigmaWin, setting up a drive, tuning a drive, testing trial operation, monitoring, troubleshooting, etc. There's also a section in here regarding installation of the USB driver. Another helpful offline tool in SigmaWin is connecting to a drive offline. What this will allow you to do is take a look at drive parameters and use some other tools. To use this tool, basically select a type of drive that you would otherwise connect to directly. In this case, we'll use the Sigma-7 Mechatrol 3. You have options here to select voltage and power capacity, as well as other options, including the number of axes and the type of motor that you would connect to. From the main menu, you'll be able to access a few different tools, such as the Edit Parameters area, where you can view parameter values as well as their descriptions, the Trace tool, where you can view previously saved trace plots, and the Mechanical Analysis tool, where you'll be able to view Bode plots that were previously created. A couple of other helpful offline tools allow you to open previously saved project or parameter files. Both of these will allow you to view a file that contains settings for drive or drives that were previously configured. We'll use the open parameter file as an example, and you can see here that you'll be able to browse through different categories of parameters and see how that drive was set up. Once a drive has been connected to SigmaWin, a control panel for that drive will appear on the left-hand side. It includes a button to take you to the main menu, as well as a status display, which indicates various conditions which may prevent the drive from operating the motor. For example, the power indicator tells you whether or not main power has been applied. When it's highlighted, that means power is applied. The HBB, POT, and NOT indicators represent the hardware base block, positive overtravel, and negative overtravel. When any of those indicators are highlighted, this means that those conditions are present, and it may prevent you from enabling or moving the motor. Clicking on the menu button will take you to the main menu for that drive, and from there you'll be able to access many of the tools that are available from SigmaWin. The main menu has a lot of different tools that are all divided into separate categories. You'll notice that some of the tools are not available. They're shown as grayed out or disabled simply due to whether or not other tools are open within SigmaWin or a state that the drive may be in. The product information tool in SigmaWin provides a lot of very useful information about the drive and the motor that you're working with. For example, it includes the model number of the drive as well as the model number of the motor, along with serial number, manufacturing date, as well as software information. If you happen to be working with any of Yaskawa's technical support personnel, this is helpful information to provide to them so that they understand the types of products that they'll be working with. While the drive control panel provides high-level status information about the drive, from the main menu, you can get to the monitor tool, which provides much more detailed information about the drive's operating conditions. When the monitor tool first opens up, you may see just a short list of information available. By clicking the clear button at the bottom of the screen, you can access a more detailed list of status information in the drive. For example, rotating speed of the motor, commanded speed or speed reference, the internal torque reference, positional angle, position error, the accumulated load ratio, which is an RMS torque, regenerative load ratio, as well as other Boolean status information, such as whether or not main power is applied, and so on. The I/O tab will let you see the current state of the drive's inputs as well as the drive's outputs. If you need to access drive parameters, you can do this by going to the Edit Parameters tool in SigmaWin. Parameters are all listed in the All Constant Number category. This is a full numerical listing, and then they're also separated into different common categories. There'll be more on this tool a little bit later. SigmaWin also includes a tool that will allow you to jog a motor in both directions at constant speed. This will be used later during the basic motion tests. With this tool, you can edit the speed at which you like to jog. When first getting started, a low speed is definitely recommended. And there are also controls for enabling and disabling motor, as well as jogging in the positive and negative directions. Another tool that can be used for moving the motor is the Program Jog tool. Unlike the Jog tool, which was just constant speed jog, the Program Jog tool allows you to configure point-to-point moves where you have control over the distance moved, accel, decel time, velocity, and also whether or not those motions are repeated in one direction or even both directions. If a drive experiences an alarm, you'll see that indicated on the control panel, and you can get more information and clear the alarm with the Display Alarm tool. From here, you can get more information about the alarm and ways in which to troubleshoot it. A button's also available to reset the alarm. Some alarms can't be reset, for example, under voltage, over voltage alarms. And the maintenance section of our manual indicates which can be reset and which cannot be. Also available is an alarm log or alarm history showing previous alarms that have occurred on the drive. An important tool within SigmaWin is the Trace tool, which is important to analyzing motion performance as well as perhaps problems that have occurred during operation. The tool allows you to configure types of signals that will be recorded, as well as trigger conditions that cause the recording to start. Data recorded from a drive through the Trace tool will result in a plot such as the one shown here. Measurement tools are available to analyze the data, and you also have save and open functions available to save this information in a file and open it at a later time. It can be very useful information for creating a record, a proof of performance, or exchanging information with people who may be helping you optimize performance or troubleshoot an issue. Whether or not a drive has main power applied can be determined best from SigmaWin using the power indicator, which will be active when power is on and inactive when main power is off. The front panel on the drive will not show when the main power is on or off. The charge LED can also be used. When main power is on, the charge LED will be on. When the charge LED is off, it's an indication that main power is off. However, there is an intermediate state where after shutting off main power, the charge LED will be on for a period of time while the drive discharges. Before starting on any work around the drive, such as wiring, mechanical installation, inspection, or otherwise, be sure to take a look at the charge LED on the drive so that you know whether or not the drive is fully discharged and that it's safe to work around that drive. An HBB condition is shown here, which occurs when a drive's HBB inputs are not powered. HBB flashes on the drive front panel and is also shown as active in SigmaWin. This example shows a case where both the positive and negative over-travel inputs on a drive are not active. PN flashes on the drive front panel, and POT and NOT both show active in SigmaWin. In this example, a drive is reporting an A.C90 alarm, which is an encoder communication alarm. A.C90 flashes on the drive front panel and is also shown in SigmaWin along with an indication that an alarm has occurred. This next section shows how to change drive parameters using the Edit Parameters tool within SigmaWin, along with other associated functions in that tool to help manage and check drive parameters. We'll show you also several different drive parameters that you may want to consider changing during the drive startup process and where to find further information on those. To open the Edit Parameters tool, first make sure that SigmaWin is connected to your drive, click on the main menu, and then Edit Parameters. And once the tool opens, you'll see a comprehensive listing of all available drive parameters. And you can find a reference for these in the drive's user manual. The user manual for a given servo drive will include a list of all servo parameters. For example, shown here is a 200-volt Mechatrol-Link Sigma-7 drive user manual, where in Chapter 13 is the list of servo parameters. This gives detailed information about the parameters, as well as links to other locations in the manual which provide further information. This is a very helpful reference to have on hand as you go through the initial drive setup. The first parameter that we'll take a look at is the motor direction selection, which allows you to configure whether positive direction is defined as clockwise or counterclockwise rotation of the motor. Clicking here will open a drop-down that gives you access to those options. Just to the right of a parameters drop-down menu is another tool that allows you to read current values of a parameter from the servo drive and also write a changed value down to the servo drive. There are also buttons for these functions on the toolbar, such as the Edited Parameters button, which downloads values for any parameters that have been edited, and the All Parameters, which downloads all parameters to the servo drive. Also, if there are several parameters that you need to change, you can make all those changes first before downloading the new parameter values to the drive. If you're planning to connect the drive to a DC power supply, be sure to change PN001.2 so that the drive expects a DC power input instead of the default of AC. It's important to change this parameter before connecting the main circuit voltage to the drive. There are some cases where the default absolute encoder mode of multi-turn absolute may need to be changed to either incremental mode or single turn absolute. This can be done with PN002.2, the absolute encoder usage. By default, the Sigma-7 servo drives are expecting three-phase AC power. If you happen to be using a single-phase power supply, this can be specified using PN00B.2. There are a lot of different parameters built into Yaskawa's Sigma-7 servo drives. When you have the all constant number category selected, as shown here in the Edit Parameters tool, you'll get that full list of parameters. But other categories can be selected to provide a filtered list of parameters. For example, selecting the position category will allow you to very quickly and easily get to the electronic gear ratio parameters for numerator and for denominator. These parameters effectively control the positioning units used by the drive, and so it's a good idea to check their values and also set them for your application requirements before continuing with drive startup. By going to the torque category, you can quickly get to the torque limits that are available for forward and reverse direction. During an initial drive startup, it's not a bad idea to consider temporarily lowering these limits for protection and for safety. The sequence category also has a couple of parameters which can be helpful to change during the initial drive setup. For example, the position deviation, overflow alarm level, PN520, and also PN522, which is the position completed with. PN520 is the maximum amount of position error that can occur before an alarm, and PN522 allows the drive to determine when it has settled into position. By going to the I/O sign category, you can get to the parameters which define whether or not a drive is expecting to see positive and or negative travel inputs, which by default the drive is expecting to see. Changing the parameter to a value of 8 will effectively, setting these parameters to a value of 8 and then writing those to the servo will tell the drive to ignore those inputs. You can do this first for the positive over travel parameter and then follow up with a setting of 8 for the negative over travel input, writing to the servo after setting each of those parameters. Or you can use the Edited Parameters button to send both parameter values down to the drive. Both the positive and the negative over travel input parameters require a power cycle or soft reboot after they've been set. SigmaWin contains a soft reset function back in the main menu, which allows you to perform that soft reset on the drive, which is the same thing effectively as a power cycle. Once the software reset has been completed, or if you chose to do a power cycle, take a look at the drive panel and you'll note that the POT and NOT indicators are now inactive. You can also go back in the Edit Parameters interface and back to I/O sign, and by using the Read All Parameters button, you can verify that the parameter values for the POT and NOT functions have been changed. SigmaWin has several different tools available for helping to manage parameters that are in a drive as well as parameter files that you may have saved. We'll show some of those here, for example, comparing parameters against defaults or against an existing parameter file, restoring parameters to their defaults, as well as saving and loading parameter files. Our servo drives have quite a few parameters available, and it can sometimes be helpful to figure out which parameters have changed from the default values. Using Compare with Defaults, will show you exactly that information. You'll be able to see each individual parameter, which is different from the defaults, as well as the default setting and the current setting of that parameter. Sometimes this list of different parameters can be pretty large, so it can be helpful to filter by category. For example, using the IO sign, we can see that the POT and NOT parameters have been changed. Another useful comparison that can be done within SigmaWin is comparing against an existing parameter file. This is a useful comparison to do if you're not sure what parameters are in a drive and if they reflect what should be in the drive. Also, if you have a servo axis that's misbehaving, it can be useful to compare parameters against a known good working file. And just like when comparing with defaults, you can use the category selections available in Edit Parameters to filter the full list of parameters by individual categories. And once you're done with the comparison tool, just click the End Compare and Apply button to go back to the main Edit Parameter screen. Once you've progressed far enough through the setup process and have the motor and drive operating as you need them, maybe to a basic degree or maybe meeting all of your performance requirements, it's a good idea to save a copy of the parameter file with those settings. Use the Export button and select USRS or ServoPack file, and then provide a descriptive name. It's a good idea perhaps to give an axis a label, such as x-axis as shown there, and then maybe a date or condition that represents those parameters, like retuning, for example. Parameters from an existing file can also be loaded through SigmaWin using the Import button. Select a USRS or ServoPack file, and then browse to the file that you'd like to load. After the file is loaded, you'll notice that some of the parameters within SigmaWin indicate that they're different than they were before. They're colored green. This doesn't mean that they've been downloaded to the servo drive, and so you'll need to follow up by writing all the edited parameters down to the servo drive. When certain drive parameters are changed, they require a power cycle to become active, a power cycle or a software reset actually. The software reset can be found back in the main menu in SigmaWin. You'll need to close the Edit Parameters window first, then click on Software Reset and Execute. And this process takes a couple of seconds, but the drive will remain connected to SigmaWin. And then once the software reset has completed, those parameters which were changed will now be active. If you need to restore the factory defaults on a drive, from the Edit Parameters tool, select the Initialize button. You'll see a warning because every parameter in the drive will be restored to factory defaults. And some of these parameters do require a power cycle. And for this, you can either do a hard power cycle on the drive, or, like we've seen before, use the software reset function. Just be sure to close the Edit Parameters tool before going to select the software reset function. And this process takes a few seconds. However, the drive will remain connected to SigmaWin. And once the software reset is complete, the drive will be restored fully to factory default parameters. And you can actually see an indication of this on the drive panel where the POT and NOT conditions are indicated. This means that those functions are active because by default, the drive is expecting to see positive and negative over travel switches. This next section will introduce a couple of tools that can be used to generate basic motion on your motor and mechanical stage if you have one coupled. Before going into this tool, some cautionary notes. First is, it's a good idea to keep the mechanical system as simple as possible. An unloaded motor on a bench top, clamped to the bench top, is a great way to go. A simple setup like that can help you identify basic issues that you may have with the system when you're first getting started. For example, motor phase wiring, brake wiring, and things like that. Now, it's not that it's necessary to have an extremely basic motor setup when you're first getting started. It's just more of a helpful way to proceed. You can also connect your full mechanical system, and Yaskawa's tuningless mode generally does a great job of getting those types of system running without requiring further tuning. However, there are some mechanical configurations that could be quite challenging for the tuningless mode, and from which you may not get the best results. Yet another reason to keep the mechanical system simple if you can. A couple of other notes before going into the motion tools. One of them is it's a good idea to know how to disable the motor quickly or cut power to the drive if something unusual happens. For example, if the motor starts moving too quickly or moving irregularly. Also, listen for any undesirable noises, high-pitched frequencies, low-pitch humming. Watch for any oscillation or other types of undesirable movement. These might be indicators that the tuning may not be the best with tuningless mode and may need to be addressed. And last note, before going into the motion tool, is just make sure that the motor is in a location where it's free to move in both directions quite a bit, at least a couple of rotations. The easiest motion tool to get started with, and the most basic, is the jog tool found within SigmaWin. You can get to this by going to the main menu, selecting jog. When the jog tool first opens, notice the warning regarding the positive and negative overtravel switches. These switches are disabled when the jog tool is being used. This actually makes for a nice trick when you're first starting up a drive because you won't have to go in and change the positive and negative overtravel input parameters before jogging the motor. You can go straight through the jog tool and begin jogging the motor. The jog tool's main screen doesn't have too many controls on it. There's a jogging speed entry, which by default is set to 500 RPM. You can change this with the edit button, which is a good idea when you're first running a motor and drive together. 500 RPM can be quite fast. So by going into the edit interface, you'll be able to change that to a lower speed. And lower at first is not a bad idea. In fact, you can go as low as 1 RPM, which is not a bad starting point to jog a motor because really the whole idea is to make sure that you can jog a motor continuously in both directions successfully. Once you've changed the motor speed to a lower speed than the default of 500, you can turn the servo on with the servo on button and then use the forward and reverse buttons to move the motor in both directions. The forward and reverse jog buttons will stay pressed as long as you hold the mouse button down. So to stop the motor, just release the mouse button. Choose one of those directions and move the motor continuously, and keep an eye on the motion and listen to how it sounds. Is the motor moving continuously and in the same direction, or has it stopped? Is it moving smoothly, or is it bouncing around, vibrating? Is it moving quietly, or are you hearing noises at high frequencies or low frequencies? These all can be indications of something that needs to be addressed with the motor. Now, another tool that's very helpful is the monitor tool. This is not necessary when you're first jogging the motor around, but it can be very helpful to open and specifically to watch the internal torque reference as you jog the motor. The idea of watching the internal torque reference in the monitor as you jog the motor is to see if the motor's torque stays at a fairly constant low value as the motor is jogged in one direction, or if, for example, the torque reference ramps up to a very high value, for example, the full continuous of 100%. And by the way, that's the range that you're looking at here. Percentage is based on the continuous torque for the motor of 100%. And what you want to see when you're jogging the motor at a low speed in one direction is that the torque reference is fairly low. If the motor seems to be moving well jogging at a low speed, you can go into the edit speed area and increase the speed. 100 RPM is not a bad next point. You can certainly go at the highest speed you like, but it's always a nice idea to go gradually through the speed range and just check and make sure that there are no issues along the way. And again, using the forward and reverse jog buttons, holding those down will allow you to jog the motor continuously. Again, keep an eye on the internal torque reference and just make sure that it's staying at a relatively low value. While jogging the motor at this higher speed, notice in the monitor tool, the top two items, the motor rotating speed and the speed reference, show 100 RPM. The motor rotating speed is the actual speed of the motor, measured from the feedback device, and the speed reference is the commanded speed for the motor. When you're done jogging the motor, maybe at this speed or different speeds, you can use the servo off button to disable power to the motor. And that button can also be used at any point in time if the motor is vibrating or moving irregularly. You can use that button to disable the motor. There's not much more to show with the jog tool, and as you can see, it's a very basic tool allowing you to move the motor at constant speeds in either direction. Another tool that SigmaWin has for creating motion is the Program Jog tool. This is more involved than the jog tool, which simply moves a motor in either direction at constant speed. The program jog tool allows the user to define point-to-point positioning profiles, which can be used for different purposes, anything from basic motion tests to burn-in testing, and also testing out profiles which will be used in the application. The program jog tool allows the user to define different aspects of the positioning profile, including the distance to move, the maximum speed at which to move, the ramp time for XL and decel from 0 speed to full speed and from full speed down to 0 speed, the time delay between consecutive moves, as well as the number of times that the move will be repeated. Users can also select the type of profile that they'd like to run from the drop-down shown here. Choices include forward direction only moves, which can be repeated with dwell times in between, or reverse direction moves, also with dwell times and repeated. You can also choose from profiles that alternate between forward direction and reverse direction. This one here, number 4, forward and reverse direction motion, is pretty commonly used when testing out profiles with the motor. After entering in the profile parameters and selecting the type of profile to use, clicking Apply will cause the program jog tool to display a preview of the expected profile on the left-hand side. If you need to update the profile parameters, be sure to click Apply again after that's done, and you'll be able to see the new profile previewed on the left-hand side. Here's an example of where the jogging movement speed, XL and decel time, the waiting time between profiles all change. Then clicking Apply, we can see the new profile displayed. Another example of changes to the profile are where the move distance changes. Once you change that value, click Apply, and again you'll see the preview of the new profile displayed. Something important to be aware of when using program jog are the units used for positioning. These are based on the encoder's feedback resolution, and by default, Sigma-7 motors have 24 bits, or just about 17 million counts per rev. Now, the resolution shown in program jog may not be the effective resolution used by the drive. If the electronic gearing parameters, PN20E and PN210 are used, the effective resolution may be different than the default resolution of 24 bits, so be sure to check those parameters first before using program jog. As you're setting the parameters for this first move in program jog, just keep in mind that it's not so important to make the motor move as aggressively as possible at first. In fact, starting off with a simple, fairly gentle move is a good place to start, and you can always go back later and make the motion more aggressive. When you're done configuring the profile that you'd like to run, click the Run button, and now you'll see a screen that allows you to enable and disable the motor using the servo on and servo off button, and the Execute button, which allows you to run the profile. Keep an eye on the scope plot, and you'll see a vertical blue line which progresses from left to right as the motion executes. We'll execute this again so that you can see that progress. This indicates where you're at in the positioning profile. Changing the parameters for the profile can be done by first servoing off, then click the button in the bottom right-hand corner to change the running conditions for the profile. Well, it's usually a good idea to start fairly simple and with a gentle motion in program jog. After you've shown that that works pretty well, you can go in and change profile parameters to make the move maybe more aggressive, faster, or sharper accelerations and decelerations, or perhaps even a longer move distance. It really depends on the application and what you're trying to accomplish. That'll determine what is appropriate to do next. This next example will change the number of movements from 1 to 5 to repeat this forward and reverse profile 5 times, which you can see here after the Apply button is clicked. Clicking servo on and then execute will start the motion, and you'll see the motor move forward and backward repeated 5 times. Profile jog offers users a lot of flexibility to define profiles that are appropriate for their system. It's really important to servo and motion control applications in general because requirements for a profile may be very different from one servo axis to the next, even in the same machine, not to mention very different from machine type to machine type. They may be very fast, rapid point-to-point motions with high accels and decels. They might be slower, longer distance moves where the velocity is gradually ramped up to speed. It really depends on your application, but go through this as you need to adjust the profile parameters as you see fit, execute the motion, and see how well it works. It's a good idea to start basic and make motion more aggressive from there. And by the way, the jogging number of movements is a really important parameter because once you see a profile that you like, that might be helpful to set to 0, which will execute that motion repeatedly an infinite number of times. It's very useful for burn-in testing, and it's also a technique that's used commonly during the tuning process. The trace tool in SigmaWin records and displays drive and motor activity so that users can analyze motion performance, troubleshoot issues, among many other things. Trace provides information in both high resolution and also over long time periods, and the resulting trace plots can be saved as files for later use. To demonstrate how the trace tool can be used, both the program jog and trace will be used together to generate motion and record the results. In program jog, a point-to-point move in the forward and reverse direction will be set up. It can be an aggressive move if you like, or something much more moderately aggressive, but the point is to have a profile that will move forward and reverse so we can capture the results in the trace tool. It's also helpful to move the jog program tool over a little bit within SigmaWin to leave room for the trace tool so that both of these items can be seen on the screen at the same time. Trace is a highly configurable tool which allows users to define the signals that will be recorded, the time resolution and total time for the recording, as well as conditions that allow the trace to trigger and start a recording. Clicking on the Setup button gets the user to the Trace Setting menu, and from here they'll be able to set different characteristics for the recording. For example, using the Auto Setting dropdown, they can select from a pre-configured template. After a template's been selected, clicking the Set button will apply all the settings from that template to the Trace Setting menu. The option that was selected here, Monitors Positioning from the Start, is a very practical one to start with for users going through an initial drive setup and beginning to test motion because it will allow them to record the details of the motion from the start of a profile. From the template that was selected, Monitors Positioning from the Start, the signals that will be used are the position reference speed, which is basically the velocity command, the torque reference, which is what percentage of the continuous torque the motor is going to be using during the profile, and also the position error, or the difference between the commanded position and the actual position. It's recommended that you check the high precision trace, especially when using position errors, so that you can see the full numerical range of that particular signal. The next step after selecting the high precision trace is to set up the record time for the motion. And this is done typically by setting just the sampling time. Now, the program jog tool can be used as a reference for how much time the move is expected to take. And in this example, the move will take just over 3 seconds. The sampling time will be configured to 8,000 in order to obtain a 4-second total record time, which is just a little bit longer than the expected move will take. It's a good idea also to review your trigger settings because these are a critical part of recording through the trace tool. They'll define when the recording starts. In this example, where monitor positioning from the start is used, trigger A and trigger B are defined. So you have 2 triggers. Trigger A is a positive velocity command, so it will cause the recording to start for a positive move. And trigger B is for a negative move, or a negative velocity command. A small but helpful change to the trigger settings from the monitor positioning from the start template is changing the trigger conditions from trigger A or B to trigger A only. The effect that this has is that the recordings will now start only when a positive direction move occurs, where the previous settings could have caused the recording to start on either a positive or a negative motion. And what that does is causes the resulting plot to be displayed a little bit differently from time to time if repeated motions are being recorded. No other changes are needed to the trace settings at this point, so clicking OK will take you back to the trace tool, and then clicking Start will arm trace. And now you can use Program Jog to enable the motor with the servo on button, and then to start motion use the Execute button. The trace tool will actually start the recording when the positive motion begins, but it will take a little while for the data to be uploaded. But here you can see the resulting trace plots where we have the position reference speed or the commanded velocity for the profile, the torque reference, and also the position error displayed on individual y-axes. To save a copy of the trace plot as a file, just use the floppy disk icon, navigate to a convenient folder, and provide a name for your file. These files can be opened later from the trace tool for further analysis. After information is recorded and uploaded, Trace does try to auto-scale each of the signals that are recorded so that they fit nicely onto the screen. But still, it might be helpful to adjust the y-offset, as shown here, which can be done for each of the y-axes independently using the up and down arrows at the top and bottom of each of the y-axes. Also, the scales can be changed individually using the drop-downs located below each of the y-axes, as shown here. Auto buttons can be used also to apply an auto scale to each individual signal. Another option is to change the time base for the x-axis so that you can zoom in time, starting from the beginning of the trace, as shown here. Zooming in and zooming out can be done using the magnifying glass buttons in Trace. This is an example of zooming in, where a rectangle is drawn around the area of interest. And then to zoom back out, we use the magnifying glass with the minus sign in it, going back to the original scale of the plot. All the settings that define a trace setup can be saved to a file through the setup menu. This includes items such as the sampling time as well as the time resolution, which define the total record time, the various signals, as well as the trigger conditions that will be used for a recording. After they've been saved, trace setup files can be opened later to take additional plots using the same conditions as previous plots. This is very helpful for consistency in recording drive activity. It's also very helpful if a user, for example, would like to set up a trace setup file to email to a remote user to define specific conditions under which a plot is to be taken. Another helpful option in Trace is the recording mode, either single shot or continuous. The difference between these two modes is that single will take just a single plot once trigger conditions are met and upload the data. Continuous mode allows Trace to automatically rearm the trigger for a recording so that repeated plots can be generated whenever a trigger condition is seen. The example shown here uses continuous mode to record a new move each time it's executed in the program jog tool. Our trigger is a positive direction move, so each time that's seen, Trace will update its plot. If you'd like to repeat motion, of course you can press the execute button each time you'd like to execute a move, but you can also change the program jogging number of movements to 0, and this will cause program jog to repeat a move infinitely. Repeating a motion profile like this can be very helpful in certain situations. Tuning is a great example, where adjustments are made to tuning while a motion profile is continuously updated. Other examples of where repeating a motion profile can be very helpful include burn-in testing and life testing. Sometimes it can be useful to have the trace tool record activity in an immediate mode as opposed to waiting for a trigger like the positive motion trigger we were using. This example will show how that can be done. You can use either a single shot or continuous mode for this type of recording. We'll start with a single shot just for simplicity, and then go back into the setup menu and start to make some changes. For this example, we're going to try to understand why a motor is making noise as soon as it's enabled. And the best way to start with this is to set a low sampling time of 125 microseconds so that we can have as high of a resolution capture as possible and measure the frequency of the noise that's being produced. Next, set the trigger target from whatever trigger is being used currently to no trigger. And this is exactly what will cause the trace to record instantly as soon as the start button is pressed. The motor is currently disabled in our example, and so the recording when we do an instant capture is not very exciting, just flat lines for the different signals. But once we enable the motor in a situation where the motor is making noise, you can see that there's quite a bit of activity occurring in the resulting plot. The auto buttons for each of the signal axes can be used to auto-scale the signals so that they'll fit nicely onto the plot. And then you can also offset each of those signals to separate them. You can also hide signals that you prefer not to have displayed. If, for example, you'd like to work with just a single signal, like the torque reference shown here, it might be helpful to hide other signals temporarily. Adjusting the resolution of the x-axis or the time axis can be done by using the drop-down menu shown in the bottom right-hand corner. This is a very easy way to zoom in on a higher resolution time period. And as we showed previously, any trace plots that you'd like to save can be saved as a file on your computer. There are also situations where it can be very helpful just to continuously record drive activity using an instant type of trigger. First, change the mode from single to continuous, and then once you click Start, the trace tool will begin recording. And continuing with our example of a noisy motor, you can see that the trace is continuously updating its plot with activity read from the drive. Another useful technique with the trace tool is recording drive alarms when they occur. This uses a single shot mode as opposed to continuous. And then in this example, we're going to draw from an existing trace setup file, which will load, which uses the alarm signal as a trigger. This setup file was one that was created previously, so you probably won't have a copy. And the whole idea of this trace file is to record drive activity leading up to the point where an alarm occurred. One of the most important parts of this is making sure that you have a high enough sampling time to capture the period of time that's of interest before the alarm occurs. Here we're using 5 seconds. Another important aspect is choosing the ALM signal for one of your I/O signals. This represents the alarm signal, and once that's picked, we can then use that as a trigger for the trigger target. Be sure to use a rising edge, and it's a good idea also to have a high pre-trigger percentage. This is so that most of the recording that takes place occurs before the trigger actually happens. Again, the trigger in this case is the alarm, so that trigger delay allows us to record a lot of activity leading up to the point where an alarm occurs. For this example, we'll first start the recorder and then create a position deviation overflow alarm by enabling the motor and then turning the motor by hand just enough to create enough position error that causes the position deviation overflow, or excessive position error, alarm to occur. You can see now that the trace tool has activity showing time leading up to when that alarm signal goes high. This is the point where the alarm actually occurs. And you can also see that the drive status panel is reporting an A.D00 alarm. Thank you very much for taking the time to watch this video. I hope that it helps with your coming drive startup, answers questions that you may have had already, identifies some areas that you may not have been aware of, and passes along some tips and tricks that help your startup go quickly and easily. As you saw at the beginning of the video, if everything goes well, it can take very little time to get a new drive and motor up and running, and there are a lot of tools available to check the progress and performance along the way. If you have any issues come up or questions, you need to know a little more information about something that you're trying to do with the motor and drive for either the initial startup or for future development with the motor and drive, Yaskawa has a lot of resources available to you. Just to recap those, Yaskawa's website is a great starting point. From there you can get to the Solutions Center, which has application notes and FAQs. Training videos are also available through the self-guided video training series. For example, the Sigma-7 servo tuning, which could probably come in handy later in your startup. Also, e-learning videos are available. Technical support and application assistance is available through local distributors, 1-800-YASKAWA, as well as motion support at yaskawa.com, as well as regional motion engineers. So thank you again for watching this video, and best of luck with your startup.